Hi madudes! Pag-uusapan natin ngayon ang tungkol sa Jfet or Junction Field Effect Transistors. Unahin muna natin i-discuss ang characteristics at configuration nito. Makikita sa slide na ito ang outline na bubuo sa ating presentation. Una, what is Jfet? Ano nga ba ang Jfet or Junction Gate Field Effect Transistor? Pangalawa, Jfet terminals. Ano ang tatlong terminals ng Jfet? Pangatlo, additional characteristic of Jfet. Kung ano yung mga gamit nito. At ang panghuli, Jfet subtypes. Alam niyo ba na ang Jfet ay may dalawang subtype? Kaya ihanda niyo na ang iyong kwaderno at tayo ay go, go, go! So ano nga ba ang Jfet? Ang Jfet ay isa sa subtype ng mga FETs. Kabilang na rin dito ang MOSFET. Ang mga FET ay voltage-controlled devices, hindi tulad ng ibang transistors gaya ng BJT na current-controlled o nag-ooperate depende sa magnitude ng current sa base. From the word FET or field effect transistor itself, electric field ang nagiging susi sa pag-control sa kung paano ito mag-conduct o mag-operate. Makikita natin sa slide na ito ang electronic symbol ng N-channel Jfet at ang P-channel Jfet. N-channel Jfet, ang gate nito ay gawa sa P-type material, samantalang ang channel nito ay gawa naman sa N-type material. Kabaliktaran naman nito yung sa P-channel. Kung maaalala nyo, pag sinabing P-type, ito ay semiconductors na holes ang majority carriers at electrons naman ang minority carriers. Opposite naman nito yung sa N-type semiconductors. Although magkaiba ang type of materials ng channels at gate ng dalawang ito, parehas naman sila na may tatlong terminals, which is yung drain, yung gate, at yung source. As what I've said earlier, Jfet has 3 terminals: gate, drain, and source. You can imagine this as the collector, base, and emitter terminals of BJTs respectively. Gate as the base, drain as the collector, and source as the emitter. Ang dalawang diagram na nakikita nyo ay nagpepresenta ng water analogy for the Jfet control mechanism. Water represents electrons, spigot or faucet represents source, and faucet handle represents gate. The source of water pressure can be likened to the applied voltage from drain to source, which establishes a flow of water from the spigot. The gate, through an applied signal, controls the flow of water to the drain. The drain and source terminals are at the opposite ends of the N-channel. Yung water pressure ang ating applied voltage from drain to source. Yung tubig naman ang ating electrons. Yung mismong tubo ng faucet ang ating source at yung faucet handle o yung pihita naman ng gripo ang ating gate. Nakadepende sa magnitude ng voltage o ng force na ilalagay natin sa pagbukas ng gate ang magiging flow ng ating tubig o ng ating electrons. Here are some additional characteristics of a Jfet. Jfet is used in precision-level voltage-operated controls in analog electronics. Jfet can also be used as voltage-controlled resistors, or as a switch, or even make an amplifier using the Jfet. More efficient to use than BJT since it provides low power consumption and fairly low power dissipation. FETs, specifically Jfets, are more temperature stable than BJTs, and FETs are usually smaller than BJTs, making them particularly useful in integrated circuit chips. Ang Jfet ay may dalawang subtypes, N-channel Jfet at P-channel Jfet. Para mas madali natin maalala which is which, sa N-channel Jfet yung arrow ay nakaturo papasok sa gate, sa P-channel Jfet naman nakaturo palabas ng gate. Sa tulong ng helpful mnemonic, mas maalala natin, N-channel Jfet's arrow is pointing in. So N-channel, in. P naman para palabas. The current flowing through the drain and source is dependent on the voltage applied to the gate terminal. For the N-channel Jfet, the gate voltage is negative. For the P-channel Jfet, the gate voltage is positive. Assume voltage VDD is applied between the drain and source terminals. The voltage between drain to source, or VDS, will then be positive, making the drain terminal more positive than the source terminal. Once we apply the voltage, electrons will start flowing from the source to the drain terminal, electron flow, and vice versa for conventional flow. We can see on the figure that the current ID is the current flowing through the drain terminal, and IS is the current flowing out from the source terminal. And on the figure, we see that ID is equals to IS, VGS is equals to 0, and VDS is greater than 0. And whenever VDS is positive, the two PN junctions will become reverse bias, which is why Jfet has a very high input impedance, which will make the width of the depletion region increase. Due to that, only a small amount of saturation current will flow through the PN junction. Practically, we can then consider Ig is equals to 0. Increasing the applied voltage on VDS will make the current flowing through the channel increase. Let's assume na may voltage applied tayo sa VDD. Dahil dito, magiging positive ang ating voltage VDS. Dahil rin dito, magiging mas mataas ang potential ng drain terminal kesa sa source terminal. Dahil nag-apply na tayo ng voltage sa VDD, magkakaroon na ng electron flow from the source to the drain. At pwede rin from the drain to the source kung conventional current. This diagram shows the plotting of current ID versus the voltage VDS. If we further increase the voltage VDS, we'll arrive to the point where the depletion region is touching each other. This condition is called the pinch-off. The voltage at which this occurs is known as pinch-off voltage, which is represented by Vp. Pinch-off happens when VDS is greater than or equal to Vp. Once this condition is reached, current ID will reach the saturation level, and at pinch-off, ID will be equal to 0 ampere. Once ID is gone, the reverse bias across the PN junction, which causes the pinch-off condition, will be removed, which will result to the loss of depletion region, which will make ID's value at maximum. Basically, the saturation current IDSS is the maximum current of Jfet at VGS is equals to 0 and VDS is greater than or equal to Vp. The depletion region is wider at the top of the P-type region because the N-channel acts as a series of resistors between the drain and the source terminal. Imagine a 0.5 voltage drop on each resistor. Taking the voltage drop across point C with respect to the source, we will have 0.5 volts. B is equals to 1 volt and A is equals to 1.5 volt. Since upper region has a higher voltage drop, it will be more reverse biased compared to the lower region. By increasing reverse bias voltage, the width of the depletion region will increase. Making VGS more and more negative will result to this graph, because applying a negative voltage across the VGS will make the PN junction reverse biased. This will also make the pinch-off and saturation level of the Jfet be reached at the lower voltages of VDS. Reducing the value of VGS will make the IDSS and Vp decrease, and when VGS is equal to Vp, the saturation current will be equal to 0 ampere. This is known as a cut-off region. For simplicity's sake, we can say that the device is turned off. Remember that Jfet can be operated at three regions: the ohmic region, the saturation region, and the cut-off region. For the ohmic region, the Jfet will work as a variable resistor by varying the voltage applied across VGS. For the saturation region, whenever VDS is greater than Vp, the drain current will almost remain constant, And for the cutoff region, whenever VGS is greater than or equal to VP, the current ID will be approximately 0 ampere. Let's now go to P-channel Jfet. The P-channel Jfet also works in a similar way, but the polarity of the biasing will be reversed. By applying voltage across the drain and the source terminal, the holes will start moving from the source towards the drain terminal. In this case, the channel is made up of P-type semiconductor. The charge carriers here will be holes. The VDS here should be negative, and the VGS is positive. By applying voltage across the drain and the source terminal, the holes will start moving from the source towards the drain terminal. It works the same as the N-channel Jfet, but in this case, the voltage VTS is negative. As we increase the voltage VGS, then the saturation value of the drain current will be reduced. When VGS is equals to VP, then the drain current will be approximately equal to 0 ampere. At dito po nagtatapos ang ating presentasyon. Maraming salamat po sa pakikinig at stay safe always!